Hey guys, welcome to the third video on synthesis. This is just going to be a video of running through an example of a synthesis question, right? And again, we're going to go through all the things in the toolbox so that you guys can get a little bit more familiar with them, okay? And so it says, using the library of synthetic reactions shown above, propose a synthesis of the following compound from compounds containing 4 carbon atoms or less, okay? So always when you start a synthesis, you want to look at what the product they gave you is and think about what we can do here, all right? So you can see we have an alkane here, okay? So we have an alkane, and we need to get to 4 carbons or less. And so right now, if we count our carbons, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So we need to cut this thing down, good amount. And so how exactly are we going to do this, right? So we have an alkane, and so what we need to do now is look in our synthesis toolbox, and we need to see what ends up with an alkane, right? What reaction can just give us an alkane like that? So if we look, we have where on the right side of an arrow do we have an alkane? It will be this one right there, okay? H2PDC. And they write PD, you could do H2PDC or PT, okay? And so my first step going backwards, here let's redraw. So that's just going to be H2PDC, okay? And so now the question is, where exactly am I going to put the double bond? All right, so you can put it in a bunch of different spots, essentially really anywhere, but you want to think about it in the way that can make this as easy as possible for you, okay? So let's just look at our synthesis toolbox. We're going to end up with an alkene somewhere. Looking at our synthesis toolbox, what do we do with an alkene? Well, we do this elimination reaction with it and end up with a Br somewhere on that double bond, okay? So wherever you put the double bond, the step after that is going to have a Br somewhere on that. Once we have a Br, we'd go through this reaction. And that Br is replaced with an OH. Remember, this is all going backwards. Once we have an OH, we do this cutting step. Okay? So you want to put our double bond. So essentially, wherever you put the double bond, you're going to cut around there. Okay? So you want to make this as easy as possible for you. You don't want to have too many arrows. You don't want to be sitting there writing a 20-step synthesis. So you need to just make this as easy as possible for yourself. So if you put the double bond, let's say somewhere on the end, so I had this, right? We're gonna end up putting a BR somewhere on it, right? And then we're gonna put an OH again on one of those carbons, and then we're gonna cut. And so that's going to make this much longer for you because it's all the way at the end. So we're gonna have to keep cutting this a bunch of different times. So what we're gonna do is we just put this somewhere in the middle. It cuts down the most amount of atoms at once, okay? So I could put it here, or I could put it here, okay? And so I'm just going to put it right there where I just put it, all right? And practicing synthesis is a little bit trial and error in the beginning in terms of getting used to it and knowing the optimal places to put the double bond and all that. But I'll go through the synthesis as if I put it either where I just had it there, that was bad, or let's say over there, all right? So we'll do it 2 ways. All right. Now remember, you only need to show one way on this synthesis questions, unless for some reason they ask for more than one, although I doubt they will. Okay. And so what I like to do again is once you go back one step, go forward and see if it makes sense. So we had an alkane, and going backwards, we wrote H2PDC. So you already know H2PDC from the alkene reactions is that they turn double bonds into alkanes. So that checks out. Going forward, right? Going forward doesn't mean to the left. All right, so we have an alkene. Now, our next step in the synthesis toolbox is to do something to alkene. So let's look at where on the right side of the reaction arrow in our toolbox would have the alkene. That's this reaction there. And so what it does, we're going to have OH minus or OR minus. and it's going to turn the alkene, and it's going to put a Br on one of the atoms of the alkene. Okay, so OH minus. Okay, and so we're going to put a Br somewhere. Oh, and just so you know, OR minus, we don't write it as OR. You don't keep that R just like that. You have to put something there. Same for when you're doing this one. You can't just write a carbonyl with two R, just R1 and R2 coming off. You have to actually show what was part of that molecule that you just cut. Okay? And so we can put the Br, it's got to be on one of the carbons of the double bond, so our choice is either there or there. Okay? And so yeah, so we have two choices where we can put it there. And same for here, I'm going to just move this down a little bit. So we could do this OH minus. Or right there. Okay. And so let's think now. Let's look at the top first. We are going forward when you do an elimination reaction with OH minus, the double bond you form will be the most substituted double bond. That's the most stable double bond. Okay. So what you do is you need to look at the carbon of your Br. So I'm just going to color that in blue for both of them. And you need to draw the possibilities of the double bond forming on the left or right hand side of it. Okay. So that would be essentially either like this, right? Or like that. Oh wait, sorry, that was the wrong one. Or like that. And for this one, it could either be here or could have been there. Okay. Yeah, and so that's as if we were going forward now with OH minus. So you need to make sure that you are getting whatever the original alkene was 100% of the time. Okay. So that means so we have our alkene right over here. We need to be forming that 100% of the time. So let's look at where our BRs are. The substitution of the double bond. This double bond right here on the right of our Br has two carbon substituents coming off, di-substituted. This one right here has three carbon substituents. 1, 2, 3. So that is the most stable one. So if that double bond right here, this one, will be forming 100% of the time. So if we put our Br there, right, on that blue carbon, we're going to get this one 100% of the time. And that is exactly what our original alkene was, so that's great. So putting the Br there is perfectly acceptable. Now let's look at what happens if we put our Br on that carbon. Okay, so what's the substitution of this carbon here? Oh, 1, 2, 3, tri-substituted. 1, oh no, oh yeah, sorry. 1, 2, 3. So this is a problem. We have a double bond equally substituted. So if I put the Br on that carbon right there, this one right here, because the double bond is equally substituted on both sides, we can get this 50% of the time and that 50% of the time, right? Whereas if I put the Br here, we would get this one 100% of the time. And so you need to be able to do your synthesis 100% of the time. So we cannot put the Br where we put it right here. Okay, so this is why I recommend that once you go one step back, go forward again and make sure it works. Okay, so you can see that I went backwards with the OH minus to give the Br, And then on the right side, I just rewrote it going forward, OH minus. And I drew out the two possible products of the double bond forming on both sides of the Br. Remember, one of the carbons of the double bond has to be on the carbon where the Br was, okay? And so you want to pick the one that's 100% of the time. So putting the Br at the top would be the better option. So I'm going to erase this one because that's not where a Br can go. Okay? And so we definitely know that the Br is going to end up on this one right here. Okay, and so I'm just going to erase this work over here. Now, like, you can do this stuff on your exam book, but on the answer sheet, you obviously just want to show the synthesis, not all the extra stuff you used to figure it out. And so remember, we were doing both synthesis questions of if I just changed up where the double bond was, right? And so I put the Br in two separate spots, so let's go through that one again this way going forward to see if everything works out. All right, so let's put the double bond on the two positions we could possibly have here, or we could have formed it there. And for this one, we could have formed it there, or right there. And so now let's look at the substitution to see where our most stable double bond is. Okay. So in this one, we have one carbon and two carbons right here. So it's going to be di-substituted. And over here, we're going to have one, two, three carbons. So we know that the double bond on the right-hand side is going to be that one that forms 100% of the time. Okay. And let's look at our original alkene. We had it on the other end. Okay. And so you can see that we had that alkene right here, this 2-carbon one. Yet when we put our Br in that position, where it is here in purple, we would actually form the double bond on the left because it's more substituted. So that means that this one right here, that means that having our Br right where we put it there at the top is not okay, because it would actually form the alkene right here. If I just erase this double bond, it would actually form this one. So that means our Br positioning is not correct. So, and because this is going to be the minor product, this is really going to be the one where it forms like about 100% of the time. Okay, so that Br positioning at the top is not good. So I'm going to erase that. And let's look at our other one. Okay, so we put the Br there. Let's look at our two possible products. That double bond has 1, 2 carbons coming off of it. This one has 1, 2 carbons coming off of it. Okay, our alkene is the one that we want to form right here, right? That's the alkene we want to form. Yeah, you can see that both of the double bonds that we form are equally substituted. So we can get this 50% of the time, and we can get this 50% of the time, right? We want this one 100% of the time. But because the double bonds that we can form are equally substituted, we're not going to get it 100% of the time. Which means that the Br position that we put is also not good. And that means that the alkene that we originally chose to make at the bottom right here is not good either. Okay, so you really wanted to have it how we had it above. So forming the double bond at the bottom is not going to get you full credit for the synthesis, because you're not going to be able to form it 100% of the time. Okay, so a shortcut for kind of doing these questions is, if your double bond, if you have, let's say, an alkane to start out with, and you're going backwards with H2PDC, you don't want to put the you don't want to have the double bond on equally substituted carbons. Okay, but again, always practice this for yourself, and you can develop your own shortcuts of how to do these things. So our entire bottom synthesis is not going to be good. So we want to stick with where we had the double bond originally. Okay? So this. So we have our BR. We already checked it out that it works. And so now what you want to do is we want to, we're going to want to put an OH in its place, right? That's what we want to put there. Also, I actually forgot to mention, you could have put the BR like this. Oh wait, no, I didn't. That was so not correct. We just went through that already. Yeah, I just blanked there. Okay, and so yeah, we want to just keep it where we had it right there. And so we have our BR there. Now what we want to do is we want to get rid of it. So we would use this one right over there. Okay, so going backwards, HBr, and all it does going backwards is you replace your BR with an OH right there. Okay, just put it exactly where it was. Now we have our OH there. What on the right hand side has an OH? That would be the cut step. Okay, so again, always be careful when you're doing this cutting step. Number your carbons 1, 2, 3, 4, 5, 6, 7, 8. Please number the carbons. Okay, you really don't want to get a synthesis wrong strictly because you didn't number your carbons and you inserted one or removed one on accident. Okay, yeah, it does, so you don't want to be that. You don't want that to be the reason you get this wrong. And so now what we've got to do is cut it. So we can pick two possible options. I'll go through both. Cut it through the 3 and 5 bond or the 5 and 6 bond. So let's do the 3 and 5 bond. So I'm going to just draw the carbons first. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And so you can see that we cut this bond right here, right? So now that we cut that bond, we have to draw our, our carbon substituents, right? And so, or I'm sorry, not our carbon substituents, our oxygen. And so if we look at the synthesis toolbox, the alcohol becomes a carbonyl. So we had an OH coming off of carbon 5 like this. Now we're going to have to make it a carbonyl like that. I'm just going to move this over to give some room. And the carbon of the bond that you cut that does not get the carbonyl gets a lithium off of it. Okay, it gets a lithium off of it. Remember, we must number our steps. So I'm going to put this right here on the arrow as step 1. Step 2, I'm just going to put H2O. Okay, and so let's see how many carbon atoms we have here. We have 4 on the lithium molecule, and we have 4 on our carbonyl. And so that matches out. So essentially, we can just finish our synthesis here. I'm just going to put an H there. Okay, and I'm just going to finish this synthesis out by, remember, if you see in our toolbox, when we have a lithium on the right hand side, all you do is write Li. We just change it to a Br. Okay, so that's for the blue cut. That would be the end of the synthesis. Let's see if I wanted to do the purple cut. Okay, so I'm gonna go like this. And so let's draw the carbons first. Number it always first. 1, 2, 3, 4, 5, 6, 7, 8. Remember, we cut the 5, 6 bond, so 5 and 6 should be separated. The carbon that had the OH, which was carbon 5 becomes a carbonyl now. I'm going to erase the H, draw a carbon double bond, and it had an H over there. Okay. And remember, you could have a ketone instead of just an aldehyde. If, let's say, instead of a hydrogen here, I had a carbon chain, right? So let's say, oh, I have this. I cut 5 and 6, and you see I have a 3 carbon chain right here. Let's just color it in green, like that. You're gonna, instead of an H, have this 3 carbon chain. So 1, 2, 3. Okay. So don't think it's only aldehydes you can form. You can have carbon chains as well. All right. So that's just something I wanted to tell you guys to watch out for. And so remember that the carbon of the bond that we cut that did not have the OH, which was carbon 6, gets a lithium there. Okay. And remember, we always have to number our steps for this part. So we know that 2 is always going to have an H2O, H plus, or some acid, right? And now what we need to do is look at our compounds, see which ones have 4 carbons or less to see if we're done. So the carbonyl one has 5. The lithium one has 3. So in terms of the lithium one, we're done. Okay, so we're done with the lithium one. And yet the carbonyl one has 5. So essentially we can't stop there. You can't just take this, put it right down there and think you're done. Okay, you're going to get points off by leaving it like that. You also need to continue finishing the synthesis of that one. So what you can do in this case is take the lithium and swap it for the 1. That's perfectly fine, right? Because think about it. The lithium is going to react with the carbonyl in the first step, regardless of whether we're putting it on the arrow or on the reactant side. They're still going to be the reactants together. Okay? And we'd have to just keep going with this synthesis. Now, again, you did not learn the reaction necessary to finish that, to go backwards from that. And so I will not continue off of that synthesis. So yeah, also just in case you're wondering, there can be situations where both the lithium compound and the carbonyl are not complete. Let's say they're asking for 4 carbons, yet they could be both 5 carbons. So essentially, you'd need to go off and complete both of them in one synthesis. So you could have an arrow coming off the carbonyl and an arrow for the lithium reagent going backwards too. So yeah, don't. It's possible that in one synthesis question, you could end up with a situation where you will have to essentially branch off and do 2 compounds at once. It does happen. So yeah, sometimes it could be avoided. Sometimes it just really can't be avoided. But again, this is why synthesis is pretty cool. There are a bunch of different ways to approach them. You'll see the answer key will give you one way. Yet you could do this multiple ways. Okay? And so the ideal route that using what you guys would know would end up with what we have over here. Okay? And so yeah, so that's how we would finish this synthesis. And let's just go through it going forward. Always a good idea. So we have a Br, 4 carbons, right? We have 1, 2, 3, 4, and we put going forward a lithium. And all it does is replace the Br with a lithium. Let's see our toolbox. Yep, checks out right over here, right? Good. Now, once we had the lithium, we had our, remember going backwards, it was the cut step, so it's really just combining 2 things now. So what we did is we connected the carbon with the lithium to the carbon of the carbonyl. Okay, the carbon of the carbonyl turns to an OH. Sorry, not the carbon of the carbonyl. The carbonyl itself turns to an OH, and the lithium goes away. So you could think of it as overlapping. So I'm gonna select this right here, and I'm gonna actually let's just erase the hydrogen first, so we have some room. So I'm gonna take that, and I'm gonna just put it right onto that. Add on that carbon, right? Remember that the lithium itself goes away. And so we just take essentially the bond of this lithium. You can say, here I can erase the lithium, and I'm connecting that to the carbon of the carbonyl. Okay? Do not add a carbon in this step in terms of like this. Do not think that this is a carbon right here. Be super careful about that. This is why I recommend numbering. Number after every step too. But when you're obviously putting this on your answer sheet, you don't want to number. Just be very careful. Okay, and so I'm going to overlap this. Let me draw on the lithium to avoid any confusion. Boom, put it right there. The oxygen, the carbonyl right here, I'm going to erase one of the bonds. So we had this. Erase one of the bonds, put an H. Okay, and you can see that's exactly what we had over there. So that's how you would do that. That's how you do that going forward. And of course, if you know the mechanism, you could always feel free to do it if that's easier for you. Then once we have our OH, what we did is we went forward and we put HBr, and that replaced the OH with the Br. Let's check that out. Yep, you can see it on the toolbox at the top right. That's exactly how that reaction works. That's great. And then going forward, we used OH minus to eliminate our Br and put a double bond on one of the carbons of the Br and that left carbon. So remember, when we do the OH minus, we form the most substituted double bond. In this case, the double bond that we formed is the most substituted. We put it on the right-hand side, it is not, and that's not going to be the one that forms. And then we just use H2PDC to get rid of our double bond, and we ended up at the exact compound they asked for. Okay, and so later on you'll learn the mechanisms for all of these reactions in terms of the elimination, because it's never that simple. For your purposes, at least in this exam, it's not going to get it's not going to get overly complicated. When you get to like exam 3 in material and the final in Orgo 2, the toolbox isn't as simple in terms of stuff like elimination reactions or the HBr step. But don't worry about that now. Okay, and so if something here didn't make sense, please feel free to email me or go to the CLC. If you're watching this on YouTube, feel free to comment any questions you have. That way that anyone else who has that question can also see. It'll help them as well. So don't be embarrassed by any questions you may have. And if you don't want anyone to see your question, yeah, always go to the CLC or email me. Okay? And so I will see you guys in the next video.